So let's start off. We'll find what the contour integral around 1 over z is. So this is a function 1 over z. We're going to work out this integral by Cauchy's deformation theorem. It shouldn't matter how big we make the circle around this point, as long as we don't hit the point or anything. Any circle we choose should give us the same. So we'll just pick it to be 1. And so we're going to just integrate it by parameterizing this circle by e to the 2 pi I theta, and we're going from theta is 0 to 1, and so we need to use u substitution. So we say z is equal to e to the 2 pi I theta, and then we do dz, and then we differentiate this, so we get 2 pi I e to the 2 pi I theta d theta. So we now, so this integral, it's equal to, okay, so what we're going to do now is just rewrite this into this over here, let's call it I. Then I is equal to integral from 0 to 1 now. We have 1 over z, which is e to the 2 pi I now, and dz is now this 1 over 2 pi I. Wait, I'm replacing dz, right? So this should just be, so I just need to put this in. What am I doing? There we go, done. So I've just put dz and I substituted this in for dz in this equation. Now we notice that something cancels. In particular, this e to the 2 pi I theta cancels over here. And then all we're left with is 2 pi I integral from 0 to 1 d theta. But this is just 2 pi I. So now what we notice is if I put some constant, let's say c1, right, what would have happened? Then I would have to put it down here as c1 over here as well. It would be over here, and then I would have c1 here. So you might be able to see now why we said before that 1 over z is a special term. So all these ones go to 0 if I integrate around a circle by this loop rule or something. I forget what it's called, but it just says around a loop it goes to 0 as long as it's differentiable everywhere. The residue theorem tells us what happens when it's not differentiable everywhere. This particular integral with the 1 over z, this doesn't go to 0 and gives us the residue. So that's why it's important. That's why this number up here, why we call that the residue, not anything else. And the key idea will be, when we're actually doing the integral, we will avoid working this out and just find out what this thing at the top is, and we'll say that's the residue. So that's it for this video. In the next video I'll do the other powers of z and show why they don't give a constant like this, why they have no residue. So just to be clear, this function c, this function has residue, has a residue c minus 1 at the point 0. So its res 0 would be c minus 1. Okay, see you in the next one.